Section 5.3 Inverse Functions. In pre-calculus, we have learned the definition of inverse function, and in calculus, the definition is the same. A function g is the inverse function of the function f. When f composed with g of x give you x back, and x is in the domain of g. And when g composed with f of x also give you x back for x in the domain of f. And we usually denote the inverse function g as f inverse. A function has an inverse if and only if it is 1 to 1. The graph of f contains the point x, y if and only if the graph of f inverse contains the point y, x. So these are the basic knowledge that we know from an inverse function. Let's review how we can find an inverse function. So we can take a look at the graph of square root of 2x minus 3. We notice that it's 1 to 1. So we know there must be an inverse function. And usually we'll rewrite the function using x and y. And the first step is to interchange x and y. So we write y as x and replace x as y. And we will solve for y. Square both sides, we get x squared equals 2y minus 3. Add 3 to both sides, we get x squared plus 3 equals 2y. And divide 2 on both sides, we get y equals x squared plus 3 all over 2. So the inverse function, f inverse of x equals x squared plus 3 over 2. Now what is new in calculus is that we learn how to take the derivative of an inverse function. Let's take a look at this theorem. Let f be a function that is differentiable on an interval I. If f has an inverse function g, then g is also differentiable at any x for which f prime of g of x is non-zero. Moreover, the derivative of the inverse function equals 1 over f prime evaluated at g of x. By observing this expression, we notice that the graphs of inverse functions have reciprocal slopes. Let's take a look at example number 2 on the application of this theorem. Let f of x equals 1/4 x cubed plus x minus 1. The question is asking for the derivative of f inverse evaluated at 3. So we will apply the formula. The inverse function, or the derivative of the inverse function, equals 1 over the derivative of the original function evaluated at f inverse of 3. So in this case, we will need two things. First is f inverse of 3, which is a number, and the second thing we need is f prime of x. F inverse of 3 equals what? It's the same as asking what value of x give you the value 3. So solving this cubic polynomial, we get x equals 2. So what we are really looking for is 1 over f prime of 2. And what is f prime Well, it's a simple problem. 1/4 times x cubed. Derivative is 3/4 x squared. And the derivative of x is just 1. Derivative of the constant -1 is 0. So f prime of 2 equals 3/4 times 2 squared plus 1 equals 4. And our answer is 1/4.